Okay, so first part here is accurately sketch the graph of each. So just like we were doing in the last lesson, but notice how this is the first two are in slope y-intercept form. This is in that slope point form. Okay, you don't have to rearrange it. From here, if you look at that form, this coefficient in front of the brackets, so slope is 1/2, and the point on that graph from this, opposite sign of the constant. So -5 for x and +3 for y. Okay, you're going to be asked that, guaranteed on the test. Given that equation, that form of the equation, what's a point on the line? Okay, this one here, same form, slope will be -4/3. And then in the brackets, what you do need to be careful of is making sure it's in that form. Is it y plus or minus something and x plus or minus something? If they're switched around, you need to factor out. Okay, but these are. So that's your slope. And then your point here would be +1, -4. Okay. Next one's in general form. So that, I can't tell right away what a point is and what the slope is, but a hint to you is find the y-intercept. Not by rearranging, but what's the value of x at the y-intercept? Any point on this line. What's the x value of any point on this line? 0. So if we put, so the y-intercept will be when x is 0. So if you put 0 in for x there, you can solve that equation. So you would have 4 times 0 minus 6y plus 12 equals 0. And then that's going to go to 0. You'll have -6y plus 12 equals 0. -6y equals -12. Y equals 2. So your y-intercept is 2. Okay, just by substituting 0 in. You can do it without showing any work. You're not going to get marks for the work here because you can easily put that in, cover it up with your finger. Solve that for y, right? It just means moving it over to the other side, one of the terms, and dividing. Okay, in terms of the slope, then in this case, you could solve for y, all right? Or you don't always have to find the slope to graph it. I found the y-intercept here. I could find the x-intercept as well. So the x-intercept is when y is 0. Well, if I put 0 in for y there, then I'm solving that equation. So often when it's in this general form, we graph it using the equation. So this is all here, right? So now I'll have 4x minus 6 times 0 plus 12. That goes away, right? And so I'll get 4x equals -12, so x equals -3. So now I have my x-intercept and my y-intercept. So let me graph that one right now, E. So my y-intercept of 2, x-intercept of -3. It's nice to have more points, but you can get more. Take a look. That's going up 2 to the right 3. So that's your slope, is 2/3. Up 2 to the right 3. Up 2 to the right 3. Or down 2 to the left 3. Those triangles all have to be the same. So that was E. Uh-oh. All right. Now I'll go back and do A. So y-intercept of 3, slope of 2. sec. Thanks. What is going on? Line. Fix it up. Just give me a sec here. Okay, that's better. Okay, and that is, that was A. And then B, -4. And slope of -1/2. So down 1 to the right 2. Up 1 to the left 2. That. There we go. That's better. Fix that up a bit. Look forward to getting my normal computer back. Let me just tell you that. So that's B. All right, so then the slope point forms I already found. So now I'm going to plot -5, 3. So -5 for x, +3 for y. That's a point. I'm not using a y-intercept. Then I use the slope, up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. So you can see that this is the better equation for it anyway in terms of graphing, because the y-intercept is not going to be a whole an integer. So here, if I graph this, you can see there that it doesn't go through an exact integer value. Okay, so that's why that other form was used. That was C. And then 1 -4 is here. And then the slope of -4/3. So down. So notice how I run out of space. Down 4 to the right 3. It'll be somewhere around here. That's why I have to go the other way. So up 4 to the left 3. Up 4 to the left 3. Is D. And then the last one, okay, we've done E. F is there's no Y term. So solve for X, if you can. So just rearrange that. And remember what I said in the last lesson. If it's X equals, that means every point on that graph will have an X value of 4. So every point will have an X value of 4, which means the X-intercept is 4, and every point on that vertical line. So this is going to be a vertical line. Okay. Let's choose yellow. Okay. And that is F. Okay, so take a look at those. Okay, question 2. So now it says determine the equation of the line to the right in point slope form. So remember what that is. So that's going to be y minus y1 equals slope times x minus x1. Notice how it's a good form to use because I can't tell what the y-intercept is. So I really wouldn't want to show this or guess at what the y-intercept is. So we can put it in slope y-intercept form, but we want to make sure it's accurate. So that's why we can have 2 points on here. Okay, we just need 1 point, but we need the slope. Because we have the graph, I'm just going to draw a triangle. If you didn't have the graph, you'd have to calculate it using the slope formula. But here, that's 2, 2, 4, 6, 7. So the slope is 2/7. And a point, choose one of them. I'm going to choose the positive one with positive coordinates. Sorry, positives are nicer than negatives, but totally up to you. And then you're going to have your equation y minus the y value, so this is x1, y1, equals 2/7 times x minus 5. And that's it. You do not expand anything. That's the point slope form, or slope point form. General form, remember, is everything on one side, no fractions, and x term being positive. So, and no brackets either, right? So I'm going to first expand the brackets. Okay. Then I'm going to multiply to get rid of the denominator of 7. So I'm going to multiply both sides by 7. So I get 7y minus 21 equals 2x minus 10. And then I want everything on one side. You decide which side is it going to be. My decision, which side, comes from the x term. If this is already positive, I'm going to bring everything to the right. Okay, and then I'm going to rearrange it with all the terms on the left. Okay. So that's general form. If you wanted to put it in slope y-intercept form, I would expand, do this part here, and then you would add 3. Okay? So the slope is 2/7. That makes sense. And your y-intercept, negative 10/7 plus 3. Well, 3 is 21 over 7, so that will be 11 over 7, which is more than 1, but less than 2. So estimates, if you check it, it looks like it's on track. Okay. Then part B says determine x and y intercepts of a line perpendicular to the line shown that passes through 2, 2. So 2, 2 is here. Okay. It's got to be perpendicular. So perpendicular would be, I don't know, something like, probably like that. Okay. So we have to find the exact x and y intercepts. We need to come up with the equation of it. Okay. So slope original was 2/7. Slope perpendicular, change the sign and flip it. So negative 7 over 2. Okay. Now, we know a point, so this is x1, y1. It's hard to tell if it's going to be nice y-intercepts or x-intercepts or not. I'm going to go back and use my point slope form. That works for everything nicely. So I'm going to put that point and the slope into that form. So I'm going to have, so for my perpendicular line, I'm going to have y minus 2 equals negative 7 over 2 times x minus 2. Now you could, from here, find the x and y intercepts. put 0 in for x, solve for y, put 0 in y, solve for x. I'm going to work through this and get it into that general form, just because it makes it nicer once you're finding the intercepts. So to do that, I expand. Okay. Then multiply through by 2. And I'll bring everything to the left because the x is negative here. So that's 7x plus 2y minus 18. And so my x-intercept is when y is 0. So if you take a look at that, when y is 0, you'll get 7x. So 7x plus 2 times 0 minus 18. So if that goes to 0, you'll get 7x equals 18. So x equals 18 over 7. So that is a little bit more than 2. If you look at our graph, looks like a little bit more than 2, right? Hard to know exactly. You can't get it exactly when that's going to be 2 and 4/7, right? Y-intercept is when x is 0. So that goes to 0. We'll get 2y equals 18, so y equals 9. And same with this. I think our grid doesn't have enough space, but we know it's positive, and it looks like 9 seems reasonable. So we're going to look at equations of lines and determine if they are parallel, perpendicular, or neither. Obviously, if it's in slope y-intercept form, then if you have y equals mx plus b in 2 separate equations, or 3 or 4 or 5, you're looking at the coefficient of x. So when you put it in lowest terms, is it equal? If it is, then they're parallel. Is it a negative reciprocal? If it is, then they're perpendicular. If it's neither of those, then it's neither parallel nor perpendicular. So in this case, these equations are in general form. So for this question, I'm actually going to solve for y. So I'm just going to put equation 1 here. Okay, and so to solve for y, the fastest way, because y is a negative term there, is to bring it to the right. Okay, and then divide by 3. Then I like to show y by itself on the left side. So those divide out, so it'll be y equals 5/3 x plus 6. Okay, so you divide those and those. So the slope of that is 5/3. Equation 2. Okay, now same thing. Y term is negative, so I'm going to bring it to the right. Just a little bit faster than bringing the other terms to the right. Oops, sorry. Need the 10y there. Okay, then divide by 10. And so we'll have y equals 6 over 10x plus 5 over 10, and reduce that. So 2 goes into 6 3 times, into 10 5 times, and 5/10 is 1/2. So now here, your slope is 5/3. Here, your slope is 3/5. They are not equal. Same numbers, but they're reciprocals of each other. If they were perpendicular, they would need to be negative
reciprocals of each other. So I'll call that M1 and M2. So M1 is not equal to M2, therefore not parallel. M1 is not equal to the negative reciprocal of M2, so therefore not perpendicular. Okay, so therefore these lines are neither parallel nor perpendicular. Okay, then we want to try to do questions like this a little bit faster. So let's look back at the general form here. So in the first equation, our slope was 5 over 3. Take a look. There's your 5 and there's your 3. And that's because this becomes positive 3y when you move it to the right, and then you're dividing by 3. So really it's 5 divided by 3 gives you the slope. Here it's 6 divided by 10, right? So 6 divided by 10, and then you reduce it. So really, that's how you find the slope quickly from general form. And then think about it. If this was, if you're dividing the coefficient of x by the coefficient of y, and you end up having parallel lines, these coefficients of x have to be multiples of each other, as do the coefficients of y, and the same multiple. So if you had something, say we had a different equation which was 10x minus 6y equals 5, something like that. Then 10 divided by 6 reduces to 5 divided by 3, 5 over 3. That would be this parallel to the first equation. So notice 5x times 2 is 10x, negative 3y times 2 is negative 6y. So basically by inspection, you can tell if they're parallel. And then you can also do that calculation in your head. Basically for negative reciprocals, it's switching the coefficients. So the x coefficient would become the y becomes the x, and opposite sign. So we'll kind of take a look at that in the next questions. Okay, so here, now we have two equations. They're in general form, but we don't know what the coefficient of x is. Okay, so the coefficient of x is k there, it's 2k plus 2. And we're told that they are perpendicular. Okay, so again, if we do this the long way, then, so for my one equation, now, y is positive here, so I'm actually going to leave it on the left and bring the other terms to the right, and then divide by 4. Okay, so I got y equals negative k over 4x minus 7 over 4. Okay, so your slope is negative k over 4. Then second one, we have, I'm going to keep that in brackets. I'm not going to expand out because that's the whole coefficient of x. So now to get y by itself, I'm going to bring it to the right. Okay, divide by 3. And y equals, so that's going to be 2k plus 2 over 3x minus 16 over 3. All right, so now we're told that these lines are perpendicular. So perpendicular means they are negative reciprocals. So here I'm going to write out my slope here. So these need to be negative reciprocals. So I'm going to find the slope perpendicular to this line. And so that would have, I'd flip the fraction, take the reciprocal, change the sign, it would be positive. Once I've done that, that means this has to be equal to this. Equal. All right, so set up an equation. So 4 over k equals 2k plus 2 over 3. Multiply through by 3k. So we get 12 equals 2k plus 2 times k. Expand it out. It's a quadratic. So remember, for a quadratic, we get everything on one side. Okay. Then we're going to divide. I notice that 2 goes into everything. So that's going to be 0 equals k squared plus k minus 6. Okay, and then factor it. So that's going to be k plus 3 times k minus 2. And so k equals negative 3 or positive 2. So let's look back here. So k is, so I've just found the k values, but let's put them back into our equation. So what did I say? The first one is negative 3. So I'm going to start here. I'll put in green here. So if k equals negative 3, then we'll have negative 3x plus 4y plus 7 equals 0. And we'll have 2 times negative 3 is negative 6, plus 2 is negative 4. X minus 3y minus 16 equals 0. Now those aren't actually in proper general form, but they are equations of lines that are perpendicular. And so you can see here, if I divide, so negative 3 divided by 4, okay, opposite sign. So that's going to be positive 3 over 4. Here, negative 4 divided by negative 3 is positive 4 over 3. Change the sign, is negative 4 over 3. So you can tell that they are perpendicular. So what do you notice about those coefficients? This is the same as this. This is the opposite sign. So either they have to be the same, the x coefficient and the y coefficient in the other equation the same, and the other two opposites, or the first one opposites and the other two the same. Right? They have to be opposite signs to get negative reciprocals. And so then a k value of 2. I'll do that in green again. So k value of 2 would be 2x plus 4y plus 7 equals 0. And then it's 2k minus 2. So 4 minus 2 is 2x. Oh no, so what was it again? Okay, so it is, sorry, messed that up. It's 2x. So then when k is 2, it's 2 times 2 plus 2 is 6x. And then it was minus, sorry, I just don't have it on my screen here. Be patient with me. So that's going to be 6x minus 3y. 6x minus 3y minus 16. 6x minus 3y minus 16 equals 0. Okay, so now if that's the case, think about the slope here is going to be 2 divided by 4. Change the sign, so that's going to be negative 1/2. And then here, the slope is going to be negative 3 divided by 6. Sorry, 6 divided by negative 3, which is negative 2. Change the sign, is positive 2. And those are negative reciprocals of each other. So again, you can determine this, whether lines are perpendicular, by looking at their coefficients. This one you actually had to do all the the algebraic math to get the k values. And you may have been able to do it by inspection to start, because if you take a look up here, you know that basically kx, if we could make k be 3 and then figure out what k has to be here to make it be -4, then that's one way. Now you wouldn't get both of the k values though. So then you'd have to look at multiples, and that's where actually algebraically solving is a little bit, well, definitely better. Okay. Next one, determine the equation of a line that is parallel to that equation, so that general form with a y-intercept of -4, and then put it in slope y-intercept form. So remember what I talked about. So if they're parallel, right, so if we look here, we can tell right away, if you can do it in your head what the slope is. It would be 7 divided by 2 and change the sign, so -7/2. But saying that, yeah, actually, let's do it that way. So because we're asked for slope y-intercept form first, so so you can go 2y, oh, let me change this. So 2y is -7x. So this is what you do if you're not sure. You don't want to guess, right? So -7/2, so slope y-intercept form, -7/2x, and new y-intercept is -4. That's it. You're done. General form, okay, so you could basically from either. So from here, actually, let's do it from this first. I want to get rid of my fractions, so both sides by 2. So that'll be 2y equals -7x minus 8. And then I want everything on one side. Notice how the x term is negative, so I'm going to bring it to the left. And I'm done. Okay, now what you could also do is from here, you know it has to have the same slope. So you've kind of got part of it. Okay, but you're missing that constant term. So then you think about, okay, y-intercept, it has to equal 0 in the general form, right? And y-intercept, the coordinates of that are 0, -4. So if you put in 0, sorry, here, just a sec. If you put in 0 for x and -4, really we're calling this c, right? So if we put in 0 for x, -4 for y, then we can solve for c. So that's going to be 0 there, -8 plus c equals 0, so c equals 8. And there you go. There's your general form. Okay, so either way. If you hadn't had the slope y-intercept form, then maybe you do it this way. But this is probably faster. But if you don't like dealing with fractions, maybe this way's better for you. You decide there's no one right answer for that. Okay, and then number 6, determine the equation of a line in general form that is perpendicular to that line and passing through the midpoint of the x and y intercepts. So here, first of all, we need to figure out what the midpoint is. We have to know a point that it's passing through. So remember x and y intercept. So x-intercept is when y equals 0. So that's going to be 4x minus 5 times 0 minus 40. So 4x equals 40, x equals 10. Then your y-intercept is when x equals 0. So that's going to be 4 times 0 minus 5y minus 40. That's going to go to 0, so this is going to be -5y equals 40, so y equals -8. So do a little sketch if you need to, right? So y-intercept of -8, x-intercept of 10, okay, oops, quite a straight line, and we want the midpoint. Okay, well, because those are intercepts, that's pretty easy to see. Half of 10 is 5, half of negative 8 is negative 4. Okay, so that's your midpoint. So, and we want, so that's for that equation. So now we know a point. So the point is 5, negative 4. In terms of the slope, take a look here. So slope for this one, you can solve for y, but remember it's going to be 5 divided by negative 6 and change the sign. So it's going to be 5, 6. If you need to solve for y, then go for it. It would be 5x equals 24. Actually, in this case, it's not in general form, is it? So I go 5x, and just copy it out. I'll keep the y on the left, the x term to the right, divide by negative 6. We got 5, 6x minus 4. I already had that, right? So you don't have to show that. I've got the slope. Okay, and so I want to find the line perpendicular to that. So slope perpendicular is going to be negative 6/5. Okay, so now how you get it in general form is up to you. Now you could do it the method that I just did. What we have been doing all along, I don't have the y-intercept, so I'm going to use the point slope form. So y minus negative 4 equals the slope times x minus the x value of that point. Expand out. Okay, and then get rid of the fraction. Yeah, so that's by 5. And then everything on one side. Okay, now if you knew this, right, or this slope, right, whatever one, but to get it into general form, we know that we want that slope to be negative 6/5. So the x value, the coefficient of x could be negative 6, and so basically I put these terms down. That would need to get a slope of negative 6/5. These both have to be positive or both negative. So might as well make them both positive because the x term needs to be positive anyway. Then you can put, figure out what your c is by what we did in the last question, where substitute the point in and solve for c. Give me a sec here. Oh, gosh. And so that's going to be 30 minus 20 plus c. So c will be, so that's 10 plus c. So c equals negative 10. And then you can put it back into your equation. Okay. And then determine the equation of a horizontal line passing through 6, negative 8 and slope y-intercept form. So a horizontal line, remember, is y equals the y-intercept. Okay, so it's really y equals b. Okay, now, horizontal line, if you think about graphing this, passes through 6, negative 8, and it's a horizontal line. That's 6, negative 8, so this point is negative 8. So this is going to be y equals negative 8, and it says in slope y-intercept form, so that means solve for y. You're done. Okay, then determine the equation of a line with no y-intercept passing through 4, 10. So 4, 10 is up here. No y-intercept means it's vertical line. So the x-intercept is 4. So that's going to be x equals 4, and it says in general form, which means you have to have one side being 0.